Good day, students. You are welcome once more to the continuation of your screencast. Today we shall be looking at the second section of this module, which is on calculus. We shall be looking at functions, relations, and limits. What is a function? A function is a relation in which each unit input, x, which is our domain, these are the values of x, has only one unique or one output y value, which is the range. Now, a function gives you one unique value of the domain to give you a unique value of your output, which is your range. Now, a relation is when an input value just gives you an output value. But when it becomes the fact that the input value does not repeat itself to give a unique value of y, it's a function. So in essence, we can conclude that all functions are relations, but not all relations are functions. The subset of x consisting of all the x for which f of x is defined is called the domain. As I've said earlier, the set of all elements in the y in the form of f of x, that's another way to write your y, which is your output or your range, for some x in x is called the range. If the function name is f and the input name is x, then the unique corresponding output, which is called your ordinate, or sometimes we call it the range or the dependent variable, is called the f of x. So anytime you see f of x, it means your y value, it means your range, it means your ordinate. And sometimes also we use other letters like g of x, h of x, or sometimes we just put y. So any of these means your output or your dependent variable. Now let's look at some examples. Example 1 says if f of x, which is our output, is given as this function 2x plus 1, we are told to find your f of 0. That means if our input now becomes 0, what is our y? All you need to do is to substitute for x value as 0 in the function. And that's what you see me doing now. So it will be 2 times 0 plus 1. That is going to give you 1. So it means for our input value of 0, the output, which is our f of 0, will be 1. B. If it is f of 3, it means input value becomes 3. If you substitute 3 there, it will be 2 times 3 plus 1, which is 7. So it means our output will be 7 if our input is 3. For f of minus 4, I put it there as my input. It will be 2 times minus 4 plus 1, that is minus 7. So it means for an input value of minus 4, the output is minus 7. Let's look at example 2. In example 2, f of x is given as minus 7x plus 1. If I'm to find f of t plus 1 becomes my input now. So I substitute it for x there. So it becomes minus 7x, open brackets, t plus 1. If I open the bracket there, I'm going to have minus 7t minus 7 plus 1. And that gives me minus 7t minus 6 by collecting like terms. The b part says f of x plus 3. X plus 3 becomes my input. If I put it there, it will be minus 7 into bracket x plus 3 plus 1. Open the bracket there, we're going to have minus 7x minus 21 plus 1. That gives you minus 7x minus 20. The c part, f of x plus h, becomes, your input becomes x plus h. I've substituted for x, I'm going to have minus 7 into bracket x plus h, bracket close plus 1. Open the bracket there, we're going to have minus 7x minus 7h plus 1. There are no like terms. Excuse me. That means we take this as the final answer. Let's now look at operations with functions. In operations with functions, we will be looking at using the addition, subtraction, multiplication, and division of functions. If f of x equals 3x minus 1, and g of x equals x squared plus 3x, find a f plus g of x. It means it will be f of x, open the bracket, plus g of x. And that's it there. So we take those two functions and we add them. We collect like terms. The like terms there is 3x plus 3x, and get this with 6x with your x squared minus 1. The B one talks about the subtraction operation. Open the bracket, you're going to have f of x minus g of x. The f of x is 3x minus 1 minus, you need to put that in brackets because you're dealing with a negative sign. And then when you open the bracket and collect like terms, you're going to have minus x squared minus 1. Example 3 is the multiplication operation. So this gives you f of x times g of x. And if I do that, I'm going to be opening the bracket using your FOIL system. If you open the bracket there and simplify, you're going to be having 3x cubed, not 3x squared, 3x cubed to the power of 3. So it means my power is going to be 3. So let me just change it there. And then this, that's what you should have. And then this times that is 6x squared, 9x squared minus that gives you that, and that will give you that. And then last question there is for the division, f over g of x. So it's going to be f of x divided by g of x, which is that divided by that. Here, that's the final answer. But in some questions, you will find that you can simplify either the numerator or the denominator. And then if you can do that, you should simplify or factorize, and then you get the final answer. Let's now look at more examples on operations. Example 4 says, given f of x equals to 4x minus 5, you're told to find a, f of x plus h, and b, f of x plus h minus f of x over h. So let's do the first part. Our input now becomes x plus h. So I put it there for x, which is there, we plug it in there. Open the bracket, you have that. And then since there are no like terms, that becomes your final answer. So that's your output there. For the other one, your f of x plus h is the same as the value you have there. So if I plug it in there, as I said there, minus f of x, which is 4x minus 5 in brackets because of the negative side. If I open the bracket, the 4x will cancel out, and then minus 5 plus 5 will also cancel out. And then I'm left with 4h over h. I cancel out the h, my final answer is 4. Let's look at this example. Given f of x equals 3x squared minus 2x minus 1, find f of x plus h. I plug it there for the values of x, and that's it there. You open the bracket first for x plus h squared before you multiply by 3. Don't multiply by 3 and then open the bracket. You open the bracket first, and then you multiply by 3, and that gives you that. Open the bracket here, that gives you this, minus 1. Here, there are no like terms, so that becomes our final answer. The B part there says you should find the f of x plus h minus f of x over h. Now, this is my f of x there. I will just repeat it there. Minus my f of x. My f of x will give me 3x squared, which I need to put there, minus the whole of this. If I put it there, bracket closed. If I open the bracket here and collect like terms, I should be left with this. And then if you bring out a common factor here, which I think should be h, you'll be left with this final answer, 6x plus 3h minus 2. Thank you. Let's go on now to the composite functions. In the composite function, it is more or less like talking about a function of a function, in which case a function, the composition of f and g denoted by f composite g is denoted by the rule. How do we know the rule? If I write something like this for you with a small circle, that is the composite function. It means the g of x here becomes the input to be plugged into the f of x function. Let's look at an example. So in this case, it said given f of x equals to that, g of x equals to that, and h of x equals to that. You're told to find f composite g of x, and then write down the domain of that composite function. Let's first of all find that first part, the f composite g of x. It means my g of x becomes my input, so I have to rewrite it that way. F into bracket g of x. So it means my g of x, which is x plus 3, will be plugged into the x value as my domain. And that's what I'm doing here. You can see it is 2, and my x now changes to x plus 3 to the power of 2. And then we go further to open the bracket and multiply by 2. And if you do that, you're going to have this as your final answer. Let's look at the second part of that. Still looking at the g composite f of x, write the domain of this as g composite f in the interval notation. We're going to be doing that also. Let's first of all find the g composite f of x. So it means my f of x becomes my input, which is that. So I will replace that. If we go up now, in the place of x here, I will replace with the 2x squared. And that's why you have that. That g ought not to be there. That should be your final answer. Now, let's quickly look at writing the domain of that in interval notation. Now, if you look at it, how do you find the domain? It means what values of x should you put here that will make this equation to be true? And this means any value can be put here to make this equation to be true. So it means all values of x, all real values, let's put it that way, all real values of x all real values of x are true for the function. In interval notation, if you want to write it, we can write it as open bracket. Let me now use the negative infinity. So it will be negative infinity is less than or equal to that x, and x is less than or equal to that. That becomes, it means any of our real values will work to give us a true value. Let's now look at the second part, finding the interval notation. Also here, the same will hold true for the question, because there is no value of x that will not hold true here, that will not give you a true value. So it means all real values of x also here will be true for this as our interval notation. Let's now go to C part. In the C part, we're told to find h composite g of x, write the domain of also that in interval notation. The first thing is that my g of x becomes my input, which means x plus 3 will be substituted in h. If you look at the question on top, this is my g of x. I will substitute or plug it in there for x. That's what I'm doing there. And you can see I'm plugging it in there. You are allowed to open the bracket under the root sign, and that will give you root of x plus 2. That is the composite function. Now the domain means what are all the values of x that will be true for this, that will not make this equation to be untrue. Remember that the root sign of any negative number will not work. So the first thing to do is to say, let's equate this to 0, x plus 2 to 0, and solve for x. It means x will be equal to -2. Now, what does that tell us? It tells us that any value less than -2 will not work, because if I should use -2 here, it will be okay, but any value less than -2 will not work. So the domain is x should be greater than or equal to x should be greater than or equal to -2. That is my values that will suffice here. Okay, now that's all about that. We shall be continuing from there next time. Thank you.